Okay.
Bing bong.
2.6 is drawing scatter plots and best fitting lines. This is what will be on your quiz tomorrow, looking at pictures like this and telling me things about them. Okay? A scatter plot is a graph of a set of data pairs, x and y. If y tends to increase as x increase, then the data has a positive correlation. Okay? So right here, you have an example of a positive correlation. The data all seems to kind of be going up together. Okay? If y tends to decrease as x increase, then the data has a negative correlation. This sort of looks negative, right? It's all kind of falling. If the points show no obvious pattern, then the data have approximately no correlation. No correlation, okay, just a bunch of data. So tomorrow on your quiz, you're going to have to look at like 3 of those and tell me which one's negative, which one's positive, which one's no correlation.
Wait, so we don't have to do best fit?
No.
I failed that.
So yes, so can you handle looking at data and seeing if it rises, that's positive correlation. If it all tends to be falling, it's negative correlation. And if it all just seems scattered and crazy, that's probably no correlation, okay? Okay. So then it says, describe the correlation shown by each scatter plot. The one that says cellular phone subscribers and cellular service regions from 95 to 2003, the left column one, is that what type of correlation is happening there? Katie, don't be confusing people.
Positive.
Positive, thank you. And on the right, what type of correlation is happening there, Jackie? Negative. Eddie's got it. No, you're fine, Eddie, I like it. Beautiful, negative, okay? Now, with correlations, numbers represent some of our correlations too, okay? A correlation coefficient is denoted by the R, by R. It is a number from -1 to +1, okay? That measures how well a line fits a set of data pairs x and y. If R is near 1, the point lies close to a line with a positive slope. If R is near -1, the point lies close to a line with a negative slope. If R is near 0, the points do not lie close to any line. So this would represent a negative correlation, a 0 would represent no correlation, and a 1 would represent a positive correlation. Does that make sense? You need me to repeat that? So R is like your correlation coefficient. They give it the term R. And when you look at these graphs and decide, okay, that's a positive correlation, then you have to tell me, where does it best fit? Is it between 0 and 1? Do you think it's like halfway of a perfect line? Is it a perfect line? And you're assigning a number with it, essentially. So if it's like halfway between being perfect and not perfect, I would say it's 0.5, a positive 0.5. If it's clearly a straight line, it's 1. Does that make sense? So you're kind of guessing and giving some numbers. We're gonna practice. Okay, so this is what they're gonna look for you to do. It says, tell whether the correlation coefficient for the data is close to -1, -0.5, 0, 0.5, or 1. So that first set of data, right here, does this data tend to look like it's falling, rising, or there is no pattern? Okay, so like right here, these dots almost look like they're falling, kind of, right? If I drew a line like that, there's pretty many that are close. So it's probably a negative correlation. Now we have to decide, is it perfectly negative? Does it make a perfect line?
No.
No, so it's probably closer to -0.5. So when I give it a correlation rating, okay, is what I'm gonna say, I would say -0.5, okay? What about this middle graph right here? You say 0, why 0? Does it look like there's a line anywhere in that graph? Could I connect? Where do you think there's a line? Yeah, if I connected this data, okay, it would be like this, right? Well, not even, it'd be like, okay?
No, like right in the middle.
I know, you're saying if I draw a line like this.
Yes.
Yes, but there's only one dot that's close to that. Okay? This has no correlation there, okay? So this rate is going to be 0. Okay, sometimes they're kind of tricky because it is a little, that should be very obvious. Positive, negative, or no correlation. Positive. And look at this, if I draw a line through here, what do you think it is? It's 1. Because almost all of those points are right on that line. Yes. There is no line that can go through here. Like if I draw a line this way, only one point goes through it, yes? And nothing else is really on top of that line, like close to it, okay? If I draw a line this way, okay, there's not much that falls on that either. These points are very scattered. Over here, they look a little bit better because there's about 3 right in a row. You see how these are almost in a row here? Okay, and there's like 1, 2, 3, and kind of this 4th one right here in a row, like these. Okay, that's how I know it's negative. This has nothing that looks like a pattern. They're just tricky. You have to just kind of pay attention to them. So that one is a 0 correlation because it has no correlation. No means 0. So then we have 3 more to look at. Okay. On these 3, tell me on the first one, what do you think the correlation is? Do you think it's positive, negative, or no correlation on number 1? Why do you say positive? They're all kind of going up. Okay, and if I draw a line from here up, what type of, if that's positive correlation, what type of number would you assign it? 0.5 or 1? 0.5. Okay, what about this second one? Yeah, that's really obvious. And so what number would we assign that? -1. And what about over here? No correlation, so we would assign it 0. Okay? So that's what we're kind of looking at. Now, for the correlation coefficient for the set of data is near positive or -1. Okay? If I have data where it is the correlation number is -1 or +1, I can create an equation for the best fitting line for that. Okay? Now, when we do it next year, it's beautiful because we just plug the data in our calculator and it gives us an equation. But this year, we're going to do it by hand. Okay? So, the first thing you have to do is draw a scatter plot of the data. Okay? So, step 1 is draw a scatter plot. I'm writing this so that we can have it for. The second step is to sketch the line that appears to follow most closely to the trend. This is why doing this on graph paper is important, and using a straight edge is important. Okay. Step 3 is to choose 2 points on the line. Two points on the line. Okay, and estimate the coordinates of those points. And then these points don't have to be original data points, so that means, if they don't have to be original data points, that means I can, from that line that I draw, I can choose a point here even though there wasn't one originally there. Okay, if I know that it crossed exactly at 1, 2, I'm gonna choose that point because that's an easy one to work with, okay? Then something with a fraction. And then step 4, you have to write an equation of the line. How do we write an equation of a line if we're using 2 points? We've already done that. How do you write an point slope? So you have to find the slope, and then you have to use one of the 2 points that you just used to put it in point slope. You're angry because this takes time, or what?
No, I thought it was wrong.
No, no, you're right. Slope first, and then point slope form. You are correct. Okay, so then we get data like this, okay? So the table shows the number Y of alternative fueled vehicles in use in the United States X years after 1997. Approximate the best fitting line for the data, okay? Kaden, you're gonna help us today,
Yes, Keating.
over there.
But I'm not the student of the week.
Don't care. You get to help today. Okay,
This is fun.
so the first set of data is 0 to 80. I say we go from 280 to 540. You're not writing on this board. Yes, that's what I want. Okay. 0 to 280. What do we only have 5, 10, 15, 20. We only have 20 blocks on there. And this ranges from 280 to 548, right? So let's just make each one 50 in the y-axis. Yep. Does that make sense? So we're gonna count up by 50 on each of them. So if the first one's at 0 to 80, graph that. Yep, that's 100, 200, that's 250, good. The second point is at 1 to 95, so it's a little above there, good. The third point is at 2, 322, yeah. And then 3, 395, and then 4, 425, and then 5, 471, and then 6, 511, yeah, 511, sorry. And then 7's at 548. Okay, now, switch my markers. Okay, so now we drew a scatter plot, yes? Now what do we have to do?
Sketch on
Okay, so,
Can't draw lines.
you can come from the starting point of 0 to 80 and just make a dotted dash line that gets close to it. You get what I'm saying? There you go. Beautiful. Perfect. Okay, so you would use a straight edge and make that sketch line nice and bold, okay? Now, choose 2 points. Are there any 2 points that pass through there?
Yeah.
Okay, tell me 2 of the points that pass through there. Okay, we chose 0 to 80 on purpose. What else passes through there? One of them does. What's that fourth point? 4, 425. Kaden, you're good. You can sit down. Thank you. Now, we're going to write an equation of a line using these. First, we have to find the slope between the two, yes? Okay, so slope of these two would be 425 minus 280 over 4 minus 0. What's 425 minus 280 divided by 4, basically, here?
Good number.
It's not negative.
No.
I should get 145. I'm gonna divide it by 4, and I get 36 and a fourth. Okay, 36.25. Beautiful. Now, I take that, right, and I do point slope form. If I'm you, I choose this point because it has a 0 in it, it's just much easier. Okay, so y minus 280 equals 36.25 times x minus 0, yeah? Y minus 280 equals 36.25x. And then all I have to do is add the 280 to the other side, correct? And you get y equals 36.25x plus 280. Now, let me tell you a little secret about doing this. Okay, in our book, for this example, it tells us the equation of the line is y equals 41.3x plus 259. Here's the deal. They have a graphing utility to use with that, and they also have like a perfect line through their stuff, okay? Here's our deal. When you go to check your answers in the back of the book, they might be off a little bit, especially the larger the numbers you're working with, the larger it might be off. But this was 41 and we had 36. That tells me that our line is pretty much the same, okay? So I'm very lenient on how I grade those, but I need to see this work so that I know where you got your numbers from and what's going on. Cool, okay.
This is fun.
And then I think we have one more thing, and then we're done, maybe one more thing. Oh, no, that was all, because the other example is all graphing calculator, so we can't do it. Okay, so that's what you're working on.